Good afternoon, everybody. We're going to be using page 76 and 77 in order to solve today's math lesson on our problem set. So we're going to be using these tape diagrams in order to look at our problem sets for today. Let me zoom in on our tape diagrams so that we can kind of have a good idea of what we're working with here. Perfect. That makes it a little easier for us to see. And we are going to basically look at how we can use this as a number line. Okay. And what we should look for here is definitely what is going to be our denominators and what is going to be our numerators here. And how do I know that my denominator is 3 for each, right? How do I know that it's 3? Well, I can easily see here that we have 1, 2, and 3. All right, 3 total. Now, to begin with, we're always starting with 0. Then we have 1 because, because it represents the first third. Then this is going to be 2 because it represents the second third. And then this is going to be 3/3. Now, when we continue and go further here, we're obviously going to circle how much is shaded. So here we have 2/3. It ends at 2/3. However, you're going to soon find out that our second fraction is going to grow. There's going to have smaller units, but it's still going to be equivalent. So let's go into our second fraction here. I'm going to still put my number line, and we're going to put lines right below our tape diagram. And here, let's find out our denominator for each. Okay, so we got 1, 2, 3, 4, 5, and 6. So we're going to put 6 below. Okay. And here I can easily see that we have to start with 0, but we're going to go with 1 because that's our first sixth, 2 because that's our second sixth, 3 because that is our third sixth, 4 because that's our fourth sixth, and 5 and 6 is our whole. Perfect. So here I am going to circle 4/6. So we go from 2/3 to 4/6. Now what we're going to do next is we have our final tape diagram, or our tape diagram. We're going to make a number line right under it. And here I need to put the lines directly below. Okay. And here we need to find out what the denominator is. And so the denominator for this one, let's find out how many units we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So this is going to be 12. Now this is going to be, I'm going to be very careful how I write these 12s. I've already messed up. So yeah, this is going to be tough. I'm going to have to write small in order to make sure that we have all these 12ths. Just really had to make these so small. And 12ths. Whew. Okay. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay. Whew. And I'm going to circle 8/12. So we go from 2/3, 4/6 to 8/12. All right. We have all of our number lines there, and our tape diagrams, and our equivalent fractions. So what they're going to be asking us is to make some number sentences using number sense using division to show. So the fraction represented in 3a is equivalent to the fraction represented in 3b. How is it equivalent? Well, we are going to show, and they want us to show using division. So I know that, let's start with 3b here, 4/6. Right? And we are using division. How does 4/6 become 2/3? Using that division, right? So how does 4/6 become 2/3? All right. And then the fraction, so you got to tell me that. What is the division? And then for 4b, the fraction represented in 3a is equivalent to the fraction represented in 3c. And 3c is 8/12. 8/12 divided by, because remember, we're using division here. And they want you to do 3a. All right, so make equals 2/3. So what do we divide 8 and 12 by to get to 2/3? Okay, perfect. For 5a, we are going to make a number line here. And you want to make your number line pretty wide. Sorry, that's really crooked. Make your number line pretty wide here, and they want us to make 0 to 1 whole. Okay, and they want us to cut this into fifths. So meaning that we have 0/5 here, and we are going to have 1/5 here, 2/5, 3/5, 4/5. That's really crooked, sorry. So 1/5, 2/5, 3/5, 4/5, and then 5/5. Okay. Awesome. And then we have 5/5 here. Okay. And then they want us to decompose 2/5 into 4 equal lengths, meaning that they want us to cut it into fourths for each one. So that's exactly what I'm going to do, but instead I'm going to represent this as 4. So 1, 2, and 3, and 1, 2, and 3, 1, 2, and 3, 1, 2, and 3, 1, 2, and 3. So now this fraction has changed, and I'm going to have the fraction be above it now. So now this is actually, so 5, 10, 15, so wait, 1, 2, 3, 4. So, oh, okay, so now we have, so 4, because this will be 4, right? 8, 12, 16, and 20. So now we have, this fifths has turned to 20ths. 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 And 20ths. And this will be 4 20ths. 8 20ths. 12 20ths, 16 20ths, and 20 20ths. So now that we've changed it, so we've cut this into more smaller units, and we multiplied it by 4. So 4 times 5 is 20, so that makes sense. So now that we have what our fraction used to be just cut into fifths, now the above is cut into 20ths, because we multiplied by 4 here. So now we're going to write a number sense using multiplication to show what fraction represented on the number line is equivalent to 2/5. And we can do this in any type of way that we want to. We can do 2/5, right? Because it says 2/5, right? It's going to be equivalent to 8 20ths. So we can show 2/5, and let's multiply that by that 4, right? And what is going to be the equivalent fraction? And then they want you to use division to show what fraction represented on the number line is equivalent to 2/5. So this at 8 20ths, right, divide by that 4. And then what's it going to come out to, right, when we divide by 4? So it's just showing us that we can have fifths here, and we can multiply that by 4 to get equivalent fractions.